Okay, welcome back. So in this video, we're going to look at another way that we can represent the formulas of um, sequences, and those are recursive formulas. Okay, and basically the idea of a recursive formula is you want to be able to write an equation that relates the next term to the previous terms of the sequence. Okay, so before the formulas we had kind of dealt with was like something like this, where a of n equals like 3n plus 1. So in other words, it tells you whatever n that you have, you just replace n in the equation and you get the the term that you want in the sequence. But for recursive formulas, this is not recursive. Recursive formulas look a little bit different. They look like something like this, where you have a sub n is equal to a sub n minus 1 plus 2a sub n minus 2, or something along these lines, where you have previous terms, right? N is 1 bigger than n minus 1 and 2 bigger than n minus 2. So n minus 1 and n minus 2 come before n in the natural numbers, and so you're figuring out, if you know the two previous terms of this sequence, you can know the next term of the sequence. So let me kind of show you how this works. So it will also tell you with this some starting values. Let's say that we know that a sub 1 is 0 and a sub 2 is 1. Okay? And then we know we're using this recursive equation. Okay? So what we want to do is let's find the first 5 terms of this sequence. Okay? So to find the first 5 terms of this sequence, what we do is, well, I know A1 and A2 already, right? So I've got 2 terms just off the bat we've already got. So now what I'm going to do is I want to find A3, right? That's the next term in this sequence, okay? So we want to find A sub 3, or the third term of this sequence. So what I'm going to do is I can use this formula here, this recursive formula, to figure out A3, because an is here, right? So n would be 3 in this situation. So everywhere there's an n, I'm just going to replace it with 3. So this would be the same as a sub 3 minus 1, right? Everywhere there's an n, put in a 3, plus 2 to the 3 minus, or sorry, 2a to the a sub 3 minus 2. Okay, there we go. So there is basically what this recursive formula would tell me, right? And so what happens when I simplify this? Well, 3 minus 1 is 2, so we're doing a sub 2 plus 2 times a sub 3 minus 2 is 1. So I want to do a sub 2 plus 2 a sub 1. Well, I already know a sub 2 and a sub 1, so I just have to plug those in. A sub 2 is 1, and a sub 1 is 0. Okay, so I've got 1 plus 2 times 0 is just 0, or in other words, 1 would be my answer there for a sub 3. Okay, so we found a sub 3 by using this recursive relationship and then the previous two terms of my sequence. Okay, let's do another one. So we just found a sub 3, right? We need to now find, because we were looking for 5 terms, we need to now find a sub 4. Okay, so we do the exact same thing here. It's just instead of plugging in n equals 3 like we did here, we plug in n equals 4. So we do a sub 4 minus 1 plus 2 times a to the 4, a sub 4 minus 2. So when we subtract these, we get a sub 3 plus 2 times a sub 2. And so now all I have to do is, what is a sub 3? Well, we just figured it out. It was 1, right? We just figured it out. It was 1. And then what was a sub 2? It was also 1. Okay. Okay. So you're just taking the previous terms and plugging those in to get what the next terms would be. Okay, so we've got 2 here plus 1 is 3. So that's a sub 4. Okay. Last thing, we need to find a sub 5, right, for our 5th term. So let's just do one more to make sure we got it down. A sub 5, we plug in 5 for n. So we do a sub 5 minus 1 plus 2, a sub 5 minus 2. And so we've got a sub 4 plus 2, a sub 3. Well, we just figured out a sub 4 was 3. So that was 3. And a sub 3 was 1. So 2 times 1 is 5. Okay. So this is a different way of writing your equation for your sequence. It's called recursive because it's using previous terms in the sequence to define the next terms in the sequence. Notice you have to go back and look at what did I get beforehand to be able to get the other terms of the sequence. Okay, so in some ways this is a little bit harder than the explicit formulas, the ones where you can just plug in n directly and get the nth term of the sequence. But it is very useful for computers. They can deal with recursion stuff really nicely. Anyway, so this is how you deal with recursion, okay? And if you wanted to find more terms of this sequence, you would just keep going, right? Find a sub 6 and so on. You just keep going. Computers can do this sort of stuff all day. So anyway, this is recursive formulas for a sequence. In the next video, we're going to look at some arbitrary sequences, and we're going to try and find equations, not like this one, okay, more like the ones that we were doing before for the sequence. And so that's what we're going to be doing next.